All right, so we have moved on to the fourth video in finding derivatives of inverse functions. We are going to step away from trig functions for a few minutes because I want to show you that this process can also be used to find derivatives of other inverse trig functions, even if we don't know what the function is or its inverse. So I know that kind of seems silly, but I'm going to show you what I'm talking about here in just a second. All right, so we'll call this number 10 because it's just a continuation. All right, and let's let f and g be differentiable functions such that g of x is equal to f inverse of x. Okay, so I'm telling you that they are inverses of each other. And I want you to find g prime of x. To find g prime of x. Okay? But please understand that you can't just straight take the derivative of f to the -1 because it's not a -1 power, it's an inverse. Okay? So what we're going to have to do is we're going to have to use that process that we were just using. All right? So if I know that g of x is equal to f inverse of x, all right? Well, I can't have two functions going on. All right, so I am going to change g of x to y. And the reason that's the one I'm changing is because it's the inverse function that I want to get rid of. All right, so remember, to get rid of sine inverse, we took the sine of it. To get rid of cosine inverse, we took the cosine of it. Well, to get rid of f inverse, we're going to take the f of it. I know that seems kind of silly, but we're literally going to take f of both sides. But when I take f of f inverse, it cancels out. Okay? Now, when you look at your equation, you no longer have an inverse, at least in terms of notation, and we can take the derivative if it doesn't have an inverse in it. Okay? So how do you take the derivative of a function of something? Right? We don't actually know what the function is. It's just some sort of function of another function with respect to x. Well, we have to do it implicitly, and this is the chain rule. Okay? So implicit differentiation, all right, gives me the derivative of the function with the inside function still in it times the derivative of the inside function. That is the definition of the chain rule. On the other side, we get 1. And now we can actually solve for dy over dx just like we were doing in all of the other problems. All right, that's supposed to be a prime, not a 1. Okay. Sorry, I'm getting a little sloppy there. All right, well, what does that have to do with g of x? Well, remember, I used g of x and y interchangeably. So I can substitute it back in, all right, in place of y. All right, so what have we just shown? What have we just technically taken the derivative? We've taken the derivative of y, which was g of x, with respect to x. That's what we've done. We've taken the derivative with respect to x of g of x, which is the same thing as finding g prime. And we have just found that it is 1 over f prime of g of x. All right, let that sink in for a second. Now, if we have found the derivative of g prime, and g is the inverse of f, then technically we have found the derivative of f inverse of x. All right, so this is just another way to write it, and this is the definition of the derivative of the inverse of f. Okay, so this is something you will want to keep in the back of your mind. If you want the derivative of the inverse of f, then you can technically jump straight to 1 over the derivative of f with the inverse of f inside. So the derivative of f evaluated at f inverse of x. Now, that still doesn't really help us find the actual inverse or its derivative, because we would have to know a lot more stuff. But we can use that to find the derivative at a point, okay? And that is more, so other than finding derivatives of inverse trig functions using this process, you're really going to use this process to answer some AP type questions where you're finding the derivative of the inverse at a point. Okay, so for the rest of this video, we're just going to be looking at some AP exam type questions. Okay, AP exam questions. All right, so we'll pick up, this is technically number 11 in our notes, our first AP exam question. All right, so let f be a, you know what, I'm going to pause the video just so it doesn't, I don't take forever, right. Okay, so here we go. Let f be a differentiable function such that f of 3 equals 15, f of 6 equals 3, f prime of 3 equals negative 8, and f prime of 6 equals negative 2. The function g is also differentiable, and g of x is equal to f inverse of x for all x's. And I want to find g prime of 3. All right, so I'm going to go through the process one more time just to show you that you will always get this formula that we got in on the last slide. All right, so since we know g of x equals f inverse of x, if I rewrite that as y equals f inverse of x, and then take the f of both sides to get rid of the inverse, that will allow me to actually take the derivative. I just have to remember to use the chain rule when I take the derivative of the left, and then divide, and back substitute g of x in place of y. So the derivative, you know what, I don't want to slide it up too far because I want you to be able to see the rest of the problem. All right, but I do want to, I'm going to put that here. And instead of calling it dy over dx, technically we have taken the derivative of g. Okay? All right, so I'm going to use that formula to find g prime of 3. All right, so according to my formula, g prime of 3 is going to equal 1 over f prime of g of 3. All right, well, that's kind of interesting. All right, because nothing I gave you in the problem says g of 3. Okay, I gave you a bunch of information, but none of them say g of 3. But what do we know about g of x and f of x? we know that they are inverses of each other. And because they are inverses of each other, okay, remember the most basic definition of an inverse is that you switch the x and the y. All right, so I gave you f of 3 equals 15. I gave you f of 6 equals 3. Well, this is an x and this is a y, right? Same over here, all right? But down here, when I put the 3 in for g, that's the same thing as having the y value of 3 in f, right? So what I'm saying is, I'm saying that because f of 6 equals 3, g of 3 equals 6. That's the most basic definition of inverses. If you switch the x and the y, if you switch the x and the y, you are on the inverse. All right, so I actually gave you more than enough information. You just had to know which piece to use there. All right, so now we can simplify. G of 3 is now 6. Okay, well, to finish, I need to know f prime of 6, which I gave you. I gave you multiple ones, but I need to, you might be given more information than necessary. And f prime of 6 is negative 2. So I can use all the information that I was given and plug in values, and now g prime of 3 equals negative 1/2. So if you know the definition here of the derivative of an inverse, and you understand that that's what you're dealing with here, okay, then you just need to plug numbers in. All right. Let's do another one. And again, I'm going to pause the video real quick just to write it down. All right, for this next example, I have written the information a little bit differently, and I actually gave you a function. So I'm telling you that f of x is equal to x cubed plus x. And then I'm telling you that f of h of x equals h of f of x, which equals x. Now I want you to find h prime of 2. All right, well, the first thing you need to understand, whoa, that's really bad, is that telling you that f and h composed together, telling you that if I compose f of x and h of x, and I get x for both, that tells you that they are inverses of each other, okay? This formula right here specifically means that f and h are inverses of each other, right? That is the Algebra 2 definition of being the inverse of each other. Okay? All right, so if I ask you to find h prime of 2, right, I am asking you to find the derivative of the inverse of f. Okay, so if I'm asking you to find the derivative of h, I'm really asking you to find the derivative of the inverse of f. Okay, and we have now, like, if you go back, you can go through the whole process if you want, but you don't have to if you learn the definition. It's equal to 1 over f prime of the inverse function. Okay, so if I want h prime of 2, then I need 1 over f prime of h of 2. All right, so I've got numbers plugged in. That means I need to know what h of 2 is. All right, well, I didn't give you information like I gave you in the last one. So how am I going to find h of 2? Okay, Well, because h of x is the inverse of f of x, when x equals 2 for h, that means y equals 2 for f. All right, well, isn't this the same thing as y? All right, so h of 2, I can find it by actually setting f of x equal to 2. And when I find the x value that makes this equation work, it will be the answer, it'll be the y value for this one. Okay? Now, this one's not terrible. What number cubed plus the same number by itself will give me 2? Well, if you just start checking a few numbers, all right, 0 plus 0 doesn't give it to you. How about 1 cubed plus 1? Will that give you 2? Yes, it will. Okay, so then the x has to be 1, which means h of 2 equals 1. I'm going to show you an example in a few minutes, or I'm going to have you do an example in a few minutes, where if you can't figure this out by just checking a few numbers, you can make this equation equal to 0 and then use your calculator to find the solution. All right, so that is something that you can do on your own. All right, so now we come back over here, and now we know that h prime of 2 is equal to 1 over f prime of 1. Sorry, I went too far. Can't see. Okay, so now I need to finish by finding f prime of 1. Well, I didn't give you that either, but I did give you f of x. And so you can find f prime of x, and then you can plug in 1 yourself. And so last but not least, my final answer is 1/4. All right, this video is getting a little long, so I'm going to stop it here, but I do have a few more AP type questions I want to go over. So unfortunately, there's going to be a 5th video.